Hi everybody, my name is Roshan. I am an assistant professor, Humanities and Science Department, MLR Institute of Technology, Hyderabad. In today's lecture, I would like to talk about idea of classical bits and qubits. First thing is classical bit. Classical bits are related to classical computer. So, in a classical computer, informations are stored in the form of a classical bits. So, these classical bits are related to a physical system. Inside a physical system, we can store two states. Either it can be 0 or it can be 1. These classical bits are need very smaller space and they are very simple. For storing these bits requires very less electrical energies. Now, these bits are stored in a physical system. It can be stored in a silicon chip. You can think in this such a way, a charged capacitor can be stored as a state 1 and a discharged capacitor can be state 0. Or in a metal hard drive using a ferroelectric material. Using electric field, we can modulate the dipole moment of the ferroelectric material and you can store 0 and a 1 state. Or you can store it in a magnetic tape where we are going to use magnetic material. So, applying sufficient magnetic field to make it is sufficiently polarized to state 1 and magnetized to state 0. Now, how we are going to process this particular classical bits? So, if you want to flip these bits from 0 to 1, we have to use a logic gate called NOT gate. If you want to add this, multiply these particular bits, then we have to use AND gate. If you want to add these bits, zeros and ones, we need to use an OR gate. Now, whatever the operations we are going to perform using these zeros and ones, which is following a particular algebra called Boolean algebra. Now, we will see what is qubits. Qubits are related with the quantum computer. So, informations are stored inside a quantum computer is in the form of a qubits. So, these qubits are quantum objects. These are quantum particle or quantum objects. Now, what is the difference between classical bit and qubits? See, for a classical bit, we can only have the states 0 and 1. But for a qubit, other than 0 and 1 or in between 0 and 1, infinite number of states are possible. So, these infinity number of states, we are going to call it as a superposition states. These states are fragile and that they are probabilistic in nature. Suppose an example, we could have 50% 0 state plus 50% 1 state, or let us say 25% 0 state plus 75% 1 state. So, these are probabilistic in nature. In this way, in between zeros and 1, infinite number of states are possible. They are called qubits. Now, how we can create physically the qubits? One example is polarization of a photons. Photons can be polarized in many different ways. So, one polarization, either horizontal polarization or vertical polarization, we can choose as a 0 or 1 state. So, in between 0 and 1, whatever the polarized states, they are going to be act as a qubit. Now, let us think about a second example, that is a spin of an electron. So, spin can be in a clockwise direction or an anti-clockwise direction. So, it will be 0 state and 1 state. So, in between clockwise and anti-clockwise direction spinning, we are going to get a qubit. Now, as a third example, ground and first excited state of a bound electron. So, the bound electron can be in a ground level or in an excited level. So we are going to call it as a 0 state and a 1 state. So in between, wherever this electron is possessing energies, where we are going to get a probabilistic nature. So we are going to call it as a qubit. So for maintaining these physically these qubits, we required a very low temperature and very sophisticated setups. So that is why these quantum computers are costly, and we can't see it is nearby places. Now, how we are going to process these informations from the qubits? How we are going to add up 2 bits inside qubit, or multiply 2 qubits, or divide? So what are that operations we are going to perform using quantum gates? There are so many quantum gates, and examples are Pauli X gate, Pauli Y gate, Pauli Z gates, hard mod gates. Those are all examples. We will talk these things in the upcoming lecture series. Now, what are the operations which is happening? They are followed by the linear algebra, which is inside a Hilbert vector space. So for representing a qubit, we need a Hilbert vector space, and it follows an algebra of linear algebra. Parallel computation is the specialty of a quantum computer. Since we have many states in between zeros and 1, what we have is a simple problem can be think of solving by many different computers. So that is called a parallel computer. One problem which is solving by many different parallel computers. So this particular specialty only associated with a quantum computer. Now I would like to summarize the today's lecture. So first we will talk about the classical bits. It is related to classical computer. Informations are stored in a 0 or a 1 state. Only 2 states are possible. So physically, any physical system you can choose, and you can store these zeros and 1. You can take a charged or discharged capacitor, ferroelectric memory, or a magnetic memory to handle these zeros and 1. Algebras are followed by the Boolean algebra. Gates are there, OR gate, AND gate, NAND gate. So many gates can be possible. Now let us see what is qubits. So a qubit is necessarily a quantum mechanical system. So what is the specialty with the qubits is we could have a state in between 0 and 1. So these states are probabilistic in nature. So there are infinite number of states can be possible in between zeros and 1. So these particular states are called superposition states. Now how we can physically store these superposition states? So that I have told you 3 examples. Spinning of an electron, polarized photon, energy level of a bound electron. So for keeping these qubits physically, it's a costly process. That is a one disadvantage with the quantum computer, but advantage is a parallel computer. By using parallel computation, we can save lot of time if you have a quantum computer. Thank you.